Good afternoon, everyone. My name is Yves Ladokunda, and I'm here with my colleagues Pascaline, Gabriel, and Ale. We are excited to share our work on simulating a crowd radio access network or CLAN using NS3 network simulator. Our presentation will guide you through our task, the structure of our simulation, and the insight we gain from it. Task. Let's go to the task and expected outcome. Our main task was to set up CLAN in simulation where a baseband processing is centralized in the crowd. By doing this, we reduce the workload on the edge devices, which is especially beneficial in 5G network. The expected outcome of this simulation is to gain a deeper understanding of how a CLAN architecture can make a network more scalable, flexible, and resource efficient. So, our project focuses on simulating a CLAN architecture where a baseband processing is centralized in cloud. As I have said before, by moving this processing away from the edge devices. So through this simulation, you hope better understanding the benefit of the CLAN can bring to the modern data-intensive network. So let's go to the simulation structure. Our simulation structure involves 6 key steps to accurately model the CLAN architecture. So for the first one is let's start on initialization. We started by enabling command line agreements, allowing users to customize the settings like animation features. By this, it allows flexibility in settings along with logging, gave us the real-time information on the simulation performance, and made troubleshooting easier. So the second one is all about node creation. To create the core component of CLAN model, we have two things. We had remote radio heads. The nodes represent the edge devices that connect with user equipment. And also we have baseband units, a single node that centralizes all baseband processing tasks in the crowd, taking the load of RRH, remote radio heads. So the third one will be mobility configuration. So we arranged RRH in the grid layout to help to visualize the distribution across the defined area. This stationary setup allowed for forecast on analysis of network performance. So the third one is network connections. We have set a point-to-point link between RRH and BBU baseband unit. When I say RRH, I mean remote radio heads, and when I say BBU is baseband unit. Okay. So for the network connection, we have managed to set up a point-to-point link, link each RRH and BBU. These links simulate the backhaul communication between the edge devices and the central processing unit with data rates and the delay configured to real network conditions. So we can go on the fifth one, which is internet stack installation. To enable communication between nodes, we have installed internet stack on each one. So each node receives an IP address, facilitating data exchange between the RRH and the BBU. I said Above that, RRH RRH is remote radio head and BBU is baseband unit. So the sixth one is application configuration. Finally, we have managed to configure the application to simulate radio network traffic with two things. We have UDP Echo Server on baseband unit which receive the data packets, and we have UDP Echo Client on each remote radio heads which send the packets to baseband unit at set intervals. This setup mimics the real-world traffic flow, helping us to study the network behavior under simulated loads. So I can invite my colleagues to continue.
Okay, thank you. Continue working on the simulation and the animation which have been used in this our project. Let me continue talking about our codes and the simulation as well. For setting the animation, we have enabled it. The simulation utilizes the visualization tools to present the network where each node for the LH is assigned to a specific color and description for easy identification to identify where those LLHs are being centralized by the baseband unit. The animation also set up and enhances the understanding of the nodes and interaction over the network dynamics. Learning this simulation, let me go to our terminal to start learning our program so that you can see the simulation as well as the animation we have made through it. Let's continue. As you can see, let me start our simulation. Here, as you see, we are having different nodes where each client, we have been divided about the 5 nodes where each node sends a data, packet of data to a given port, like taking this client with this ID, sending the data, the packet of data to these ports with this IP address, and the server shows that those those data as well as the server sent those data received from this client one and sent to this port two, as well as also another ports here. Another client sent a packet of data to this port, and the server showed that it received those data from this client, and also the server sent those data to this port also. And this happened to all those nodes that we have been divided within this project, showing how different clients are being centralized by this baseband unit, showing the way that baseband unit is going to centralize them, sending the data that received from those clients to be processed. Let me continue showing how these baseband units are receiving the data from those nodes through the diagram. Let me show you. As you see here in this simulation, where we are having these radio remotes as the nodes that have been divided for being decentralized by this baseband unit, where let's take an example of this port. We take the packet of data and send data to a given port. Before those data are going to reach to the to the port where this node want to send the data are going to go through this baseband unit as a center, and this baseband will take the data and send them to the port where these nodes wanted to send those data. And this will all happen to all these nodes where each node will be sending the packet of data to a given port, but before those data reaching to the decide the ports where it is going to be sent. It is going to go through this baseband unit. Then this baseband unit, as a decentralized one, will send the data to the specialized ports where the data are needed. Thank you. In conclusion, for this project, this simulation effectively demonstrates the benefits of centralizing baseline processing in 5G networks by visualizing node interaction and applying realistic configuration. The program provides valuable insight into the operational advantages of the cloud LAN architecture, including those improved scalability and resource management. Through this work, we did that so that you can centralize your baseband units so that it can be controlling all the nodes connected to it to effectively transmit the data, the packet of data to the required ports. Thank you.